In the deep velvet of space there is mostly silence. A patient silence measured not in minutes or in days, but in epochs. We on our small blue world have learned to listen to that silence, to watch the darkness for the faintest flickers of movement. We are watchers, cataloguers of the cosmos, and we had found a new visitor. We named it 3I Atlas. The 3I designated it as only the third interstellar object ever confirmed to have entered our solar system, a traveller from an unknown star countless light years away. When we first saw it, it was just a smudge of light tumbling slowly, faintly on a path that was not our own. It was a ghost passing through the neighbourhood. Its trajectory was set a long, graceful hyperbola that would sling it around our sun and cast it back out into the deep to a new destination we would never live to see. It followed this path, falling inward toward the heart of our system, and then, as all such objects must, it vanished. It fell into the great blinding glare of the sun. For months it was lost to us, hidden in the solar curtain. Our most powerful telescopes were useless against that brilliance. We could only wait. We calculated its path, predicted where it should emerge, and we aimed our instruments at an empty patch of sky waiting for our traveller to return to the night. And it did. It emerged from the fire precisely where our calculations said it would be, but the object that returned to our view was not the one that had disappeared. Something had changed. The first images, the first clear data, came from the Lowell Observatory in Arizona. The team on duty was expecting to confirm one of two things. Either 3I Atlas was a comet, a dirty snowball, whose ices would now be violently boiling off, leaving a spectacular tail of gas and dust after its close solar pass. Or it was a dead inert rock, an asteroid from another system now superheated and scarred by the encounter. The data that streamed back was neither. It was impossible. The spectrographs, the instruments that meticulously break light apart to read its chemical signature, were not showing simple ice. They were not showing bare rock. They were lighting up with the unmistakable complex fingerprints of carbon. Long, intricate chains of organic molecules. 3I Atlas was not a barren rock. It was shrouded. It was coated in a thick, dark, cohesive blanket. A shell. As more observatories locked on a chilling, wondrous consensus formed. Radar mapping bouncing signals off its surface confirmed the visual data. This was not a dusting of material. This was a solid crust, a layered shield wrapped around the entire object, estimated to be between 15 and 20 meters thick. A 20-meter thick shell of complex organic material on an object that came from another star. The questions came faster than the answers. Where did this come from? How could such a thing exist? The answer, we realized, did not lie in its fiery pass around our sun. Our sun did not create this shell, it merely revealed it, perhaps by burning away a final thin layer of simple frost that had coated it like steam clearing from a mirror. No, the origin of this shield was far older, forged in a place we can barely imagine. It was born in the cosmic forge. To understand this shell, you have to understand the journey. 3I Atlas is ancient, far older perhaps than our own Earth. It was likely born as a simple planetesimal, a chunk of ice and dust in the cold outer disk of its home solar system billions of years ago. It was a mix of simple ices, water, methane, ammonia, carbon dioxide, the basic stuff of the universe. But it did not stay there. Some ancient gravitational disturbance, a wandering giant planet, a passing star, flung it from its cradle. It was ejected, exiled into the lonely interstellar dark, and for billions of years it drifted. We think of interstellar space as empty. It is not. It is a void, but it is a violent void. It is flooded with cosmic radiation. High-energy particles, the hearts of atoms, are shot across the galaxy by exploding stars, by supernovae. They are tiny, invisible bullets travelling at nearly the speed of light. This radiation is the hammer of the cosmic forge. The surface of 3I Atlas, its simple frozen ices, was the anvil. For billions of years, this is what happened. A high-energy cosmic ray would strike the surface. It would shatter the simple frozen molecules of methane or water. It broke them apart into their base components, fragments of carbon, hydrogen, nitrogen. These orphaned atoms, reactive and searching for stability, would immediately try to recombine. But they didn't just reform into water and methane. They formed new, more complex, more stable things. They linked up into long, sticky chains. Carbon atoms, the backbone of all life we know, latched onto each other, creating a dark, reddish-brown, tar-like substance. This process is agonizingly slow, a few new molecules every century perhaps. But 3I Atlas had time. It had billions of years. More time than our world has hosted life. Molecule by molecule, layer by layer, the shell was built. The constant, relentless rain of cosmic radiation acted like a universal hammer, forging this dark organic sludge, curing it, hardening it, linking it together until it became a solid, impenetrable crust. The very radiation that created the shell also made it stronger, locking the molecules into a near-indestructible matrix. This forge is a paradox. It is both creation and protection. The same cosmic rays that would destroy any delicate, pristine material were harnessed by simple chemistry to build an armor against them. That is what we are seeing. A 15 to 20 meter thick shield of ancient, complex organics built by the universe itself. And the most exciting part is not the shell. It is what the shell has been doing. It has been protecting what is inside. Hidden beneath that armor, locked in a cold that has not changed in billions of years, lies the object's original core, the primordial matter. The pristine, untouched ices and dust from the very moment its home solar system was born. 3i Atlas is not just a visitor, it is a time capsule. It is a messenger carrying a sealed sample of another cradle of creation delivered to our doorstep. And now, for the first time, we are beginning to see what lies inside. But as we drift closer, as we move past the simple fact of its arrival, the portrait of this visitor begins to change. The initial sketch of a simple comet, a traveller from the cold, begins to blur. And as our instruments focused, as we gathered the light and decoded its secrets, a new image emerged. It was not the face of a familiar friend, it was the portrait of an anomaly. The first brushstroke of this strange portrait was its very breath, the gas it was exhaling. We know what comets are. We have studied them for centuries. We call them dirty snowballs, and for a good reason. They are fundamentally chunks of ancient ice, mostly water ice. When a typical comet from the long darkness of the outer solar system swings in towards our sun, the warmth touches it. That water ice doesn't melt, it turns directly into gas. This process, sublimation, creates the beautiful glowing atmosphere, the coma, and the long streaming tail. We expect this. We expect a comet to be full of water. A normal comet's composition is predictable, perhaps 60, 70, or even 80% water. 3i Atlas was not normal. When we pointed our sensors at its glowing halo, the water was almost gone. It wasn't just low, it was astoundingly scarce. We found only 4%, a tiny insignificant trace. It was as if we had found a river in the desert, only to realize it was just a morning mist soon to vanish. So if it was not breathing out water, what was it made of? The answer was carbon dioxide, dry ice. This object was not a dirty snowball, it was a mountain of frozen carbon dioxide moving through our solar system. This is not just a small difference, it is a fundamental one. It means 3i Atlas was not born in the same nursery as our other comets. It must have come from a place far, far colder, a region of space so frigid that carbon dioxide freezes solid, but perhaps where water is less common. Or it suggests a history, a formation process that we simply have no model for. This composition puzzle was the first great question. Where does such a thing come from? It was a visitor, yes, but it was a visitor from a place we did not know existed. It was a stranger speaking a chemical language we'd never heard. And this was only the beginning. The gas was strange, but the dust it carried was even stranger. When a comet releases its gas, it also releases the dust that was trapped within the ice. This dust trails behind it, and by catching the sunlight, it allows us to see what the comet is truly made of. We use a tool called spectroscopy. It's a way of reading the fingerprint of light. Every element, every molecule glows in a very specific way. We looked at the fingerprint of the dust from 3i Atlas, and what we found sent a quiet shock through the scientific community. We found the expected elements. We found iron, we found nickel, we found cyanide. These things are common in the cosmos. They are forged in the hearts of dying stars and scattered across the galaxy. Finding them was not the surprise. The surprise was the ratio, the specific amount of one element compared to another. In nature, these ratios are set by the laws of physics. When a star explodes, it creates nickel and iron in a very predictable ratio. The asteroids that float through our solar system, the dust between the planets, they all share this natural signature. The signature from 3i Atlas did not match. It didn't match any natural meteorite we have ever held. It didn't match the dust from any other comet. The ratio of nickel to iron and the ratio of nickel to cyanide was wrong. It was so wrong, in fact, that it looked less like natural cosmic dust and more like a refined industrial alloy. The kind of material that is not found but made. The kind of ratios you get when you purposefully process metals in a furnace, separating them, purifying them and mixing them for a specific purpose. Scientists being careful ran the numbers. They asked what is the probability that some unknown natural process could create this specific chemical signature? What are the chances that this is just a cosmic fluke, something nature created that we have simply never seen before? The probability they calculated was less than 1%. A profound silence follows a discovery like that. Here was an object masquerading as a comet made of the wrong gas and shedding dust that looks manufactured. The implications are enormous, and yet they are whispered. Because what do you say? What do you conclude? You can only look deeper. And that is what we did. We looked at the third piece of the puzzle. Not the gas, not the dust, but the light itself. The light bouncing off that dust. This part is a little more complex, but is perhaps the most baffling clue of all. Sunlight as it travels from the sun is unpolarized. You can think of it as light waves vibrating in all directions at once. When this light hits a surface like the ocean, or a highway or a particle of comet dust, it bounces off, and in that bounce it becomes organized. The waves tend to start vibrating in one specific direction. This is called polarization. We have studied the polarization of light from every comet, every asteroid, every planet in our solar system, and they all follow the rules. They all reflect light in a very predictable way. They give us what we call positive polarization. 3I Atlas did not. This visitor, this stranger, did something with the sunlight that we have never ever seen. As we watched it, it reflected the light with an extreme negative polarization. This is not supposed to happen. It breaks every model we have. It defies our understanding of how light interacts with dusty surfaces. It means the very structure of the dust itself, its shape, its composition, its texture is completely alien. It is nothing like the fluffy, porous natural dust grains we have always found. This single fact, this strange light, is perhaps the most profound mystery. It is a physical phenomenon without an explanation. It tells us that whatever this object is, it's not only made of strange materials, it is built in a strange way, a way that shatters our physics. And so the portrait is complete, a body made of frozen carbon dioxide from a place we do not know, dust that carries the chemical fingerprint of an industrial alloy, and a reflection that breaks the known laws of light. This is the anomalous portrait of 3I Atlas. It is not a simple comet, it is a riddle that passed silently through our home, leaving behind only questions. It asks us to sit with the unknown, to be comfortable in the mystery. It reminds us in the deep quiet of the cosmos that the universe is not only stranger than we imagine, it may be stranger than we can imagine. And as you settle deeper now, let these questions go. Let them be mysteries for another day. Let them dissolve like starlight into the quiet darkness. Just drift. In the grand, silent ballet of our solar system, there is a defined choreography. Everything moves together, born from the same spinning cloud of ancient dust. The planets, the asteroids, and most of the comets all travel in the same direction, a vast counterclockwise procession around our sun. It is the path of least resistance, the way the river of gravity flows. And then there was 3I Atlas. It did not follow the music, it entered the stage moving backward. This is what we call a retrograde orbit. It means that while the Earth, Mars, and Jupiter are all circling one way, 3I Atlas was circling the other. Imagine stepping onto a highway where every car is moving at thousands of miles per hour, and you decide to drive against the traffic. This is not just rare, it is fantastically dangerous. But the true strangeness, the part that makes this dance seem less like an accident and more like a performance, is where it chose to do this. Most comets that dare to go retrograde, these lonely rebels, tend to do so in orbits that are tilted far away from the main highway. They dive in from high above or sweep up from far below, avoiding the chaos of the planetary lanes. Not 3I Atlas. It chose to perform its backward dance on the ecliptic plane. This is the flat level disk where all the planets travel. It was driving the wrong way in the busiest lane at the busiest time. The chances of this happening by random capture from the Oort cloud, the calculations are staggering. The probability is estimated to be around 0.005%. Less than one chance in 20,000. It is an orbit so unstable, so statistically impossible that it should not exist. It's like finding a single perfect snowflake balanced on the point of a needle in the middle of a hurricane. This bizarre path meant that 3I Atlas was not just a passive visitor. Its journey was a gauntlet of near misses. It didn't just fly by our solar system, it flew through it. Its orbit forced it into a series of gravitational encounters, a series of cosmic flybys with the giants. It skimmed the orbit of Jupiter. It threaded the needle between the asteroid belt and Mars. It made a close, intimate pass by our own world. Each flyby should have been its last. Each encounter with a planet's immense gravity should have torn it apart or flung it out of the system forever. Yet it held its course. It used the gravity of our own planets not as a hazard, but as a tool, refining its path, slowing its approach, turning its impossible orbit into a precise scheduled arrival. It was a dance so complex, so perilous, and so perfectly executed that it felt planned. As this celestial dancer moved against the flow, it began to reveal more of its impossible nature. We all know what a comet should look like. It is a cosmic voyager with a glorious tail. This tail made of dust and gas is pushed by the solar wind, the constant breath of the sun. This is a fundamental law. The tail always points away from the sun. It is the comet's flag streaming in the stellar breeze. But 3 Atlas broke this law too. As it neared the sun, astronomers began to see something that baffled them. Yes, it had the normal tail streaming away from the sun as expected, but it also had something else, a bright focused plume of material that was shooting forward. It had a jet that pointed towards the sun. This phenomenon, which they called the anti-tail, seemed to defy physics. It was not the pale fan-shaped illusion we sometimes see from heavier dust particles. This was an active focused jet. It was pushing against the solar wind. Imagine trying to swim up a powerful waterfall. Imagine a boat trying to sail directly into a hurricane, not being pushed back but actively forcing its way forward. This is what we were witnessing. What could cause this? The theories were desperate. Was it a magnetic effect, a pocket of magnetism within the comet so powerful that it was interacting with the sun's own magnetic field in a way we had never seen? Was it a chemical reaction? The ice on its surface, composed of materials so exotic that when the sun touched them they exploded with a force that could counteract the solar wind itself? Or was it something else? In the quiet of the observation rooms, a new unsettling thought began to form. This jet was not a random outburst. It was controlled. It was propulsion. The deviant dancer was not just moving backward, it was actively steering. It was fighting the sun, and it was winning. The dance had become a duel. The final act of this performance came at its most dangerous moment, perihelion. This is the comet's closest approach to the sun. It is the moment of maximum heat and maximum gravitational stress. It is the fiery test that separates cosmic travelers from cosmic dust. Many comets do not survive. They crack, they fracture, they disintegrate into a cloud of ice and rock, their long journey ending in a final silent puff of steam. We watched, we waited for 3 Atlas to break. Instead, it ignited. As it plunged toward the sun, it did not just get brighter, it flared. It suddenly and dramatically increased in magnitude, becoming so bright that for a few nights it was almost visible to the naked eye. It became a new temporary star in our sky. But it wasn't the brightness that held our attention, it was the colour. As the sun's intense radiation boiled its surface, 3i Atlas revealed its true heart. It began to glow with a deep, vibrant and unnatural green. We have seen green comets before. The colour is a chemical fingerprint. It comes from molecules like diatomic carbon, a simple organic building block which glows green when lit by the sun's ultraviolet light. But this was different. The green was too green. The intensity was off the charts. It was a vivid, shocking emerald, a colour so pure it seemed to challenge the sun itself. Observers described it with a phrase that echoed through the astronomical community. It was greener than the sun. This impossible colour told us that the comet's composition was unlike anything we had ever sampled. It wasn't just ice and rock. It was packed, saturated with complex organic materials, the very molecules that form the basis of life. The sheer quantity of this material, enough to create a glow that rivaled a star, was staggering. The deviant dance was complete. The backward-moving comet, the one that fought the sun's own wind, had arrived at its destination and announced its presence not with a whisper, but with a brilliant green flare, the colour of life itself. And as it began its slow, deliberate journey back out away from the sun, it was heading for a new, very specific destination. It was heading for us. When we first saw this visitor, we assumed it would play by the rules of gravity. These laws, mapped out by the Newton and perfected by Einstein, are the universe's great predictable rhythm. They govern the waltz of planets, the curve of light, and the paths of celestial travellers. We pointed our computers at Oumuamua, fed them the data on its speed and direction, and calculated the precise, elegant arc it should take as it fell toward our sun, whipped around it, and was cast back out into the dark. This path, dictated by the sun's immense gravitational pull, was our baseline. It was the test. And for a while, Oumuamua passed. But then something strange happened. The numbers didn't quite add up. Our telescopes watching its every move reported a tiny persistent discrepancy. After it passed the sun, as it was heading away from us, it began to speed up. It was moving slightly faster than our calculations said it should be. It was accelerating. This wasn't a powerful sudden thrust, it was a gentle continuous push, a non-gravitational acceleration, a whisper of a force pushing it away from the sun, a force that gravity alone could not explain. Now in the cold, empty expanse of space, this is not entirely unusual. We have a very common explanation for this. We see it all the time. It's what comets do. Comets, as you know, are the solar system's ancient snowballs. They are beautiful chaotic bodies made of ice dust and frozen gases left over from the birth of the planets. When a comet gets close to the sun, the warmth of that star does something magical. It doesn't melt the ice. It sublimates it. The ice turns directly into a gas, bypassing the liquid stage. This gas erupts from the comet's surface in powerful jets. You can think of them as tiny natural rocket engines. As these jets shoot gas and dust out in one direction, they push the comet in the opposite direction. This is outgassing. It's the reason comets develop those magnificent glowing tails and their fuzzy, bright atmospheres, which we call a coma. And this process, this gentle, constant thrust from venting gas, is a perfect example of non-gravitational acceleration. So the mystery was solved, perhaps. Oumuamua was simply an interstellar comet warming its ancient ice by our star's fire. This was the simplest answer. It was the most logical explanation. But science demands proof. If Oumuamua was outgassing, if it was behaving like a comet, it must have the telltale signs of a comet. It must have a coma. It must have a tail. And so we looked. We pointed our most powerful eyes on Earth and in space at that single moving point of light. We used the Sitzer Space Telescope, an instrument so sensitive it can see the faint heat from distant objects. We used the Atacama Large Millimeter Submillimeter Array, or ALMA, a vast network of dishes in the high deserts of Chile designed to see the cold, faint glow of gas and dust clouds between the stars. If Oumuamua was outgassing, ALMA would see the carbon monoxide. Spitzer would see the water, the carbon dioxide, or the dust. To produce the tiny acceleration we measured, Oumuamua would have had to shed a lot of material. The calculations were stunning. To get that push, it would need to have vented by some estimates as much as 5 billion tons of its mass during its flyby. 5 billion tons! That is not a subtle event. That is a colossal cloud of gas and dust. It would have created a brilliant sprawling coma, a cloud far larger than the object itself, reflecting the sun's light, glowing brightly for our telescopes to see. We searched for this cloud, we stared and we waited, and we found nothing. There was no gas, there was no dust, there was no coma, there was no tail. The space around Oumuamua was empty. It was clean. It was just a tiny tumbling object glowing with the faint reddish light of reflected sunshine. Yet it was undeniably accelerating. It was pushing itself forward with an invisible engine, a force that left no trace. This is the central paradox of Oumuamua. This is the omitted variable. We were left with an effect but no visible cause. We had a test based on all our knowledge, our models of gravity from Einstein, our models of comets from decades of study, and the result was a contradiction. The object was accelerating, but the fuel was missing. The engine was silent. This is where the easy answers end and the deep, unsettling questions begin. We were forced to consider more exotic ideas. Could it be a comet of a kind we have never seen before? Perhaps it was made not of water ice, but of solid hydrogen. A hydrogen iceberg tumbling through the galaxy. Hydrogen would turn to gas at incredibly cold temperatures, and it would be completely invisible to our telescopes. It's an interesting idea, but we don't even know if a solid hydrogen object of that size could form or if it could survive a journey of millions of years through interstellar space. The simple, comfortable explanation of a comet had failed. We were left staring at the data at a puzzle that refused to be solved. We had an object that looked like a dry, rocky asteroid, but it moved with the ghostly push of a comet. It presented us with a riddle, an engine that runs on nothing we can see, a force without a signature, and as this tiny silent traveller sped away from us, accelerating into the dark, it left us with this beautiful, lingering question. What was the variable we omitted? What was the push? And so the world began to watch. It started as a quiet murmur in online forums, a shared excitement among those who spend their nights looking up. But as 3i Atlas grew brighter, the murmur became a global chorus. This was no longer just a faint fuzzy patch of light for experts. It was becoming an event. Across the planet, a great mobilization was underway. In backyards, amateur astronomers dusted off their telescopes, the thrill of discovery pulling them out into the cold night air. They were the sentinels, the first to notice the subtle changes in the comet's growing atmosphere, its coma. They shared sketches and photographs tracking the unfurling of its delicate tail, a streamer of dust and gas pointing away from the sun. At the same time, the great professional observatories, the glass and steel giants perched on remote mountaintops, began to shift their gaze. Time on these massive instruments is precious, scheduled months or years in advance. But for an event like this, schedules are torn up. The telescopes in Chile and Hawaii, the space-based observatories orbiting high above our atmosphere, all of them were retasked, turning their powerful eyes toward this single fleeting visitor. This was the window of opportunity. The comet was putting on a show, and humanity had a front row seat. It was a collective endeavour, a shared sense of wonder that bridged continents and time zones. For these few weeks we were united not by politics or borders, but by a shared curiosity, a collective gaze pointed upward at this traveller from the deep dark. Then came the climax of this great observation, December 19th. This was the day of the comet's closest approach to Earth. It would never be closer to us, never be clearer in our skies. This was our golden opportunity. All the data, all the photographs, all the excitement had been building to this moment. Now the full power of our scientific instruments could be unleashed. First, we used a technique called spectroscopy. This is how we read the light. We took the faint silvery glow of the comet and passed it through an instrument that acts like a prism, splitting the light into its fundamental rainbow of colours. But hidden within that rainbow are dark and bright lines like a secret barcode. This barcode is the chemical fingerprint of the comet. We could see clear as day the signature of water. Not liquid water, but water ice that had been frozen for billions of years and was now turning directly into vapour. We saw the fingerprint of carbon monoxide and carbon dioxide, the kind of dry ice you might see on Earth. And we were hunting for more, for the complex organic molecules, the carbon-based compounds that are the building blocks of life itself. Was this comet carrying the very ingredients that might have seeded life on our own planet all those eons ago? Spectroscopy was our way of reading the comet's ingredient list. At the same time, we used photometry. This is a simpler idea. We measured its brightness very, very precisely. We watched how the light flickered and changed moment by moment. This told us how much dust and gas the comet was shedding. Was it having sudden outbursts? These bursts act like geysers, revealing weak spots on the comet's nucleus, the solid, dirty snowball hidden deep within the glowing of fog. Then came polarimetry. This is a more subtle and beautiful technique. We studied the quality of the light itself. When sunlight bounces off the tiny dust particles in the comet's tail, it gets polarized. It vibrates in a specific direction. By measuring this, we could figure out the texture and shape of that dust. Were the particles fluffy and complex like tiny snowflakes, or were they simple hard grains? This tells us about the environment where the comet was born 4.5 billion years ago. And finally, there was the most ambitious Hope radar. From a few massive radio telescopes on Earth, we sent a powerful, focused ping of radio waves hurtling through space toward the comet. The hope was that this signal would pierce through the glare of the coma, hit the solid nucleus and bounce back. It was a long shot. The nucleus might be only a few kilometers wide, a tiny target in the vastness of space. We aimed our signal and then we listened, waiting for the faintest, most distant echo. If we got it back, that echo would allow us to build a rough 3D map of the core itself to finally see the shape of the solid heart of this celestial ghost. After the close approach, the comet continued on its path. It dived down toward the sun, swinging around it in a fiery, dangerous loop. This is the moment of greatest peril for a comet, the point called perihelion. Many comets do not survive. They are torn apart by the sun's gravity or vaporized by its intense heat. But 3 Atlas survived. It emerged from the glare of the sun changed, and now we learned even more. The comet was now heading away from the sun, but the true heating had just begun. The sun's radiation had soaked deep into the comet's core. The outer layers, which had been exposed to space for millennia, were now gone burned away. The comet was peeling back its own layers like an onion. What we were seeing now was the pristine material, the ices that had been locked away in the comet's heart, untouched since the very dawn of the solar system. The intense heat was causing these deeper layers to sublimate, to turn from solid ice directly into gas. Our spectroscopy measurements changed. We began to see new chemical fingerprints, molecules that were heavier, more complex, which had been buried deep inside. We were no longer looking at the comet's skin, we were looking at its heart. This post-perihelion observation told us about the comet's internal structure. Was it a solid uniform block of ice and rock? Or was it, as many scientists suspect, a rubble pile, a loose collection of smaller ice boulders all held together by gravity? The way it released these deep gases, the way its brightness flared and faded gave us the clues. We were, in effect, looking at a time capsule. This visitor had carried a message for us, a frozen physical sample of the cloud that gave birth to our sun and our Earth. And in those precious weeks as it looped through our neighbourhood, we learned to read it. Then, just as quickly as it arrived, it began to fade. Its long journey back into the deep, cold darkness had begun. The great observation was coming to an end, but the data we collected, the secrets we unlocked, would be studied for decades, telling us more about this ancient traveller and about our own origins. So where does this leave us? We have looked at the data, we have seen the signals, we have measured the strange heat and the impossible speed, and yet the truth feels further away than ever. This is because we are faced with a fundamental problem of perception. We are not actually seeing through our atlas, we are seeing the cloud it has wrapped around itself. We see the glowing shell of radiation and superheated dust it drags through space. It is wearing a cosmic mask. This means we are studying the journey, not the origin. We are analysing the footprint, but we cannot see the creature that made it. We measure the heat, but we cannot see the engine. This mask, this veil of energy, blocks our view of the object hidden deep inside, forcing us to guess, to infer, to imagine what lies beneath. And this is why all the data seems to break the rules. We are trying to describe a face by looking only at the veil that covers it. This challenge has been called the Rubik's Cube problem. You know the puzzle. It has many sides, many colours, and every time you twist one section to solve one colour, you inevitably scramble the others. Our Anomaly 3i Atlas is a puzzle with at least 9 different coloured sides. Its speed, its intense heat, its powerful magnetic field, its strange looping orbit, its massive radiation shell, its chemical signature. Scientists are very good at solving for one colour. We have many natural theories. Perhaps one scientist suggests it is a very unique kind of comet, a massive ball of exotic ices. As it got closer to our sun, these ices would burn off, creating the huge radiation shell. This is a good theory. It explains the shell perfectly, but it cannot explain the intense structured magnetic field. A comet is a loose pile of ice and rock. It should not have a magnetic field like a planet. So another scientist proposes a different idea. Perhaps it is a magnetar fragment, the dead core of an ancient magnetic star. This would of course explain the incredible magnetism, but it fails to explain the orbit. A dense, heavy piece of a star core should travel on a clean, predictable path pulled by gravity. It should not be looping and changing its energy as if it has a mind of its own. As this is the problem. Every time a natural model explains one of the 9 anomalies, it fails to explain the other 8. Or in solving 3 of them, it makes the other 6 more confusing. There is currently no single natural explanation. No one theory that can line up all 9 colours of this cosmic cube at the same time. The puzzle right now remains unsolved. This failure of conventional ideas leads us to our first major hypothesis, one that steps just slightly outside the box of the familiar. What if 3i Atlas is not a complete object? What if it is a fragment? Imagine a vast ancient world, or perhaps a massive unknown structure that existed billions of years ago. Now imagine that object was destroyed. Perhaps it was torn apart by the gravity of a giant planet or shattered in a cosmic collision. If 3i Atlas is just a single chunk of debris from that much larger parent object, it would carry the history of that parent with it. This theory is compelling because it would explain why the object seems so unnatural. It wasn't formed this way, it was broken this way. Its strange properties are not its own, they are inherited. Its powerful magnetic field might not be self-generated. It could simply be a lingering echo, a permanent magnetic charge left over from the massive iron core of the planet it once belonged to. Its strange chemical signature might be the last trace of an atmosphere that was violently stripped away in the catastrophe. If this is true, we are not looking at a thing but at a clue. We are looking at a piece of shrapnel from an unknown explosion. We are holding a single broken piece from a machine we cannot see, and we are trying to guess what the full machine looked like. This is the fragment hypothesis. But this hypothesis must immediately face the most profound and unsettling fact of all. This is the question of age. By tracing its long, lonely path back through the galaxy, by measuring its speed and the decay of elements in its cloud, we can estimate how old this object is. The calculations are staggering. The estimates place its age somewhere between 3 billion and 11 billion years old. Let that number settle in your mind. 11 billion years. Our own solar system, our Earth, our Sun, they're only about 4.5 billion years old. This traveller, this fragment, could easily be twice as old as our world. It is a true relic from the dawn of the galaxy. Think of what that means. When the Milky Way itself was young and chaotic, when the first generations of stars were just bursting into life, this object was already moving through the void. It was already ancient before our sun even ignited. It has witnessed the birth and the death of entire star systems. It has drifted through the long quiet ages of the cosmos, a silent passenger on the galactic stream. If it is a fragment, it is a fragment of a world that died before our Earth was even born. And here the Rubik's Cube snaps back into view, presenting us with the ultimate paradox. The fragment idea and the age idea are in direct conflict. An 11 billion year old piece of rock should be cold, it should be dead, inert, it should have lost all of its internal heat, all of its energy billions and billions of years ago. It should be a frozen silent ghost drifting in the absolute zero of deep space. But 3 Atlas is not cold, it is hot. It is not dead, it is active, it is radiating energy, it is generating a magnetic field, it is behaving like something young and energetic. How can a relic from the dawn of time still have a fire burning inside it? This is the central mystery. We have an object that is impossibly old yet impossibly active. It has the properties of a broken fragment but the energy of a living system. A natural fragment of that age should be silent, but 3 Atlas is screaming into the void. These 2 facts cannot both be true. A natural object cannot be this old and this active at the same time. The puzzle cube is completely scrambled, unless the heat it is generating is not natural, unless the fragment is not from a planet but from something else, unless we are looking at something that was not just broken but built. This leads us to a place of deep discomfort. It leads us to a hypothesis that many are unwilling to speak aloud. If no natural model can solve the cube, if the object's age and its activity are a fundamental paradox, then perhaps the simplest explanation is the one we have been avoiding all along. Perhaps 3 Atlas is not a what at all. Perhaps it is a who. We must now in our journey consider the final, most unsettling possibility. We must confront the idea that this is not a relic, that it is a message, or perhaps a messenger. We listen into the great filter, into that vast, overwhelming quiet. We have sent our questions into the dark and the dark has offered no reply. We are surrounded by a galaxy of 100 billion stars, a universe of 2 trillion galaxies, and yet we seem to be utterly, profoundly alone. But perhaps the silence isn't total. Perhaps the answer isn't a shout, but a whisper. Perhaps the evidence of others is not a radio broadcast, but something more tangible, something passing by. For most of human history, we assumed our solar system was a closed garden. Everything here belonged here. The only things that came from outside were photons, particles of light from distant stars. Then in 2017, everything changed. A telescope in Hawaii scanning the sky caught something impossible. An object moving too fast. It was not bound by the sun. It was just visiting. It came from interstellar space. We named it Oumuamua. It was a shock to the system, and it was strange. It was shaped perhaps like a long thin cigar or a flat pancake. It was dark reddish and reflected sunlight in a way that meant it was tumbling oddly through space. And strangest of all, it accelerated as it swung past our sun. Something gave it a tiny gentle push away, a push we could not explain by the sun's gravity alone. 2 years later it happened again. A comet this time. We named it Borisov. This one looked familiar, I see, with a tail, but its path was also wrong. It too was a visitor from another star. And then, looking back at old data scientists, found a third fiery spark over the Pacific Ocean in 2014, a small meteor that struck our atmosphere. Its velocity calculated backward showed it also came from interstellar space. 3 in just 8 years. Our calculations, our models of how the galaxy works, they suggested we might, if we were lucky, see one such object every decade. We have found 3. This is a profound anomaly. The universe is sending us far more traffic than we expected, and this is the great question. Is this just random luck? A statistical fluke? Did we simply get much better at looking all at once, or are we living in a part of the galaxy that is for some reason unusually busy, a cosmic highway? Or is there another possibility? Is this anomaly a selection, not our selection, but someone else's? Let us just for a moment, as the night deepens, let us wonder. What if one of them, what if Oumuamua was not a rock? What would an artificial probe sent by an ancient civilization look like? What if we are searching for a message when we should be looking? Or are you looking for a messenger? If you wanted to send a ship across the gulf between stars, a journey not of centuries but of millions of years, what would it need? It would need first a shell, a way to survive. The space between stars is not empty. It is filled with radiation, cosmic rays moving at near light speed. It is filled with tiny hard grains of dust. Over 1 million years, this is like a constant sandblasting. A probe would need to be shielded. Perhaps it would be made of a metal alloy we cannot even imagine. Perhaps it would be coated in a thick hardened layer, scarred and darkened by eons of travel. It would look ancient. It would not be shiny. It might look like a reddish inert rock. And what about its journey? It would need to be efficient. A survey probe wouldn't stop, it wouldn't enter orbit. That costs too much fuel, too much energy. The most optimal path, the most efficient way to survey a star system is to simply fly through it. You use the star's own gravity like a slingshot, a gravitational assist to bend your path and fling you onward to the next target, perhaps thousands of years away. You would aim your trajectory to pass through the habitable zone, the region where planets like Earth exist. You would sweep through gathering data, listening, watching, and then you would fly right back out. And if that probe used, say, a solar sail, a vast thin membrane to catch the light of stars for propulsion, it would be pushed by that light. As it passed close to our sun, that sudden intense burst of sunlight would give it a tiny gentle push, a non-gravitational acceleration, exactly like the push we saw on Oumuamua. It is just a whisper, a what-if, a ghost of an idea. So why are scientists so hesitant to even discuss this? When we see something in the sky that looks like a ship, acts like a ship, and accelerates like a ship, why is the first, last, and only acceptable answer, it must be a rock? This is the caution of science. It is perhaps its greatest strength. There is a famous phrase in science, a guiding principle: extraordinary claims require extraordinary evidence. And claiming we have found a piece of alien technology is the most extraordinary claim in human history. The price of being wrong is enormous. Science is built on trust, on reputation, on a long, slow, careful process of observation and proof. If you cry aliens, and it is later proven to be, say, a chunk of frozen nitrogen ice flaking apart, which is a leading natural theory for Oumuamua, you risk your career, you risk credibility, you risk becoming a joke. Science must prefer the boring answer. It must assume that everything we see is a natural process, because almost always it is. The scientific method demands that we exhaust every single possible natural explanation, no matter how complex or unlikely, before we are allowed to even consider the artificial one. This caution is not a failure of imagination. It is the firewall that protects us from our own biases. It separates what is real from what we want to be real. And so we are left in this beautiful, frustrating, ambiguous place. We have anomalies. We have visitors from the void more than we ever thought possible. We have whispers, faint signals that could be interpreted in startling ways. And we have the quiet, steady, cautious voice of science telling us to wait, be patient, look closer, gather more data. The truth is still out there, waiting in the darkness. And as we drift now into sleep, we can rest in that ambiguity. We can hold both ideas in our mind, the mundane and the magnificent. The universe is silent, and the universe is whispering. It does not come as an invasion. There are no great ships darkening the sky, no sudden war of the worlds. It comes perhaps as a quiet confirmation, a set of data from a deep space probe or a series of images from a powerful telescope, an analysis of light from a distant star's atmosphere showing chemicals that have no business being there. Or perhaps it is an object, something closer to home, found tumbling in the darkness of the asteroid belt, its angles too perfect, its surface too smooth to be the work of nature. In that instant, the world we knew is gone. The news does not spread, it ignites. It flashes across the digital nerves of our planet, a sudden global collective intake of breath. This is the moment our minds were built for and the moment they are least prepared for. We are pattern-seeking creatures. We see faces in the clouds and draw stories in the stars. For our entire history, we have stared into the darkness, searching for a reflection, a pattern that proves we are not just a cosmic accident. And now the reflection has stared back. The first reaction is not from governments. It is from all of us. It is a flood, a billion voices speaking at once online. It is a torrent of awe, of fear, of joy, of disbelief. It is memes and prayers, frantic speculation and profound quiet wonder. It is the sound of 7 billion human minds all trying to process the same impossible world-changing truth at the exact same time. Citizen scientists emerge overnight. People dust off their old telescopes, pointing them at the patch of sky named in the news. Neighbours gather on rooftops, looking up, hoping to be part of it. It It is no longer just a scientific event. It becomes a human event, the single greatest story in the history of our species. We would feel perhaps very small, but we would also feel for the first time truly connected. We are not just to each other, but to the cosmos itself. The search for patterns would be over. We found the one great pattern that changes all others. We are not a miracle, we are a statistic. And in that there is a strange and profound comfort. We are not an accident, we are an outcome that has happened before. Only after this first human wave do the old structures begin to react. The pillars we built to give our world meaning, to keep us safe. Governments would scramble. They would seek to control the narrative to ensure security, to manage the panic, and to harness the potential. The question, once a fantasy, who speaks for Earth, would become the most pressing geopolitical issue of the age. Would this new knowledge finally unite us, making us a single human family facing the vast unknown? Or would this discovery become a new prize, a new technology, a new continent to be claimed and fought over? And what of our halls of learning? Academia would be reborn. Every book on biology would need a new chapter. Every philosophy class would have a new central question. We would move from if to how. How does life begin? How different can it be? Is consciousness our most treasured possession, a common feature of the universe? Or is it the true rarity the sociologists and artists would have a new canvas trying to paint the portrait of humanity when we are no longer the only subject? The great religions and faiths of the world would face a profound moment of reckoning. The ancient stories we told ourselves, are they still true? For many, faith would be strengthened. The universe, God's creation, is simply more vast, more wondrously complex than we were ever told. The divine hand is not smaller, it is infinitely larger. But for others it would be a crisis, a tearing down of the walls that made us feel special and unique. Great theological debates would echo in cathedrals, temples and mosques, a search for our new place in a cosmos that is suddenly undeniably occupied. These questions would not be destructive. They would be expansive. They would be a spur to grow to understand faith not as a wall against the dark, but as a light we carry into the dark, only to find it was already illuminated. Finally, this discovery would force us to look at that great lingering question, the Fermi paradox. For decades we have asked, where is everybody? We pointed our great radio dishes at the stars, listening for a hello, a beacon, the industrial noise of a distant city, and we heard only silence, the great silence. But we were listening for the wrong thing. The discovery we just imagined was not a radio signal. It was a tangible object, a techno-signature, a structure orbiting a distant star that is too symmetrical to be natural, a ruin on a dead world. This changes everything. The great silence is not empty. It is just quiet. The evidence of life is not a conversation, it is an echo. We are not diplomats. We are archaeologists. We are not explorers finding a new populated shore. We are brushing the dust off a shard of pottery in a city that has been empty for 1,000,000 years. The Fermi paradox. Where is everybody finds a new and perhaps more haunting answer. They were here, and they have moved on, or they have perished. The great silence is not the sound of an empty room. It is the silence of a museum after hours. It is the silence of a library filled with books written in languages we cannot yet read. We thought the great filter, that barrier that stops civilizations from reaching the stars, was ahead of us. We thought it was a test we had to pass, like nuclear war or climate change. But what if the great filter is behind us? What if the simple dumb luck of coming into being at all is the hardest barrier, and we passed it, and so did they? But we are separated by the crushing, unthinkable distances of space, and more importantly of time. We are like two people writing letters, only for the letters to take 1 billion years to arrive long after the sender is gone. This echo on Earth would change us forever. It would be the end of our planetary childhood. It would force us to look up, but also to look inward. We would have to decide as one people who we want to be in this new larger reality. The knowledge would be terrifying, and it would be liberating. We would finally know. After all the ages of wondering, all the lonely nights staring at the pinpricks of light, we would know. We are not the beginning. We are not the end. We are just one chapter in a story that is older and stranger and more magnificent than we ever dared to dream. And now, as you drift to sleep, let your mind wander. Let it touch that vast, ancient, occupied silence. Feel the comfort of not being alone, of being part of a story that has always been and will always be. Rest now. The universe is awake and it is waiting. And so we arrive at the end of our journey. Or perhaps it is the beginning of a new one. We have travelled from the birth of our sun to the edges of known space, and now we stand before this new strange artifact. We call it 3i Atlas. It is a traveller, and like all travellers it brings with it a legacy. This perhaps is the final lesson, the most important gift the traveller has given us. For centuries the stars were a painting, beautiful, distant and perfectly still. We wrote stories about them, we dreamed of visiting them, but in our hearts we believed it was impossible. The distance was too great, the time was too long, the cold dark void between the stars was a sea without a shore. We used words like light year to describe this distance. The word itself sounds heavy, like a burden, a measure of impossibility. It was a wall around our tiny solar system. We were here and everything else was out there, forever out of reach. But 3i Atlas has changed that. Whatever this object is, a probe, a message, a piece of ancient cosmic wreckage, it proves one thing beyond all doubt: the journey can be made. It crossed the impossible sea, it passed the wall. It proves that the vast emptiness of space is not a barrier but a passage. It proves that interstellar travel is possible. This knowledge changes everything. It is a new truth for humanity. The cage we thought we lived in has been shown to have a door. We may not know how to open it ourselves, not yet. We may not have the key, but we know the door is real, and that single fact rewrites our future. The traveller's legacy is the death of the word impossible. It is the birth of a new tangible hope, and with that hope comes a new kind of challenge. We are standing at a new frontier, but this is not a frontier of land or even of space, it is a frontier of the mind. We have spent our entire existence trying to find answers. We built great telescopes to see the beginning of time. We sent our own small robotic messengers like Voyager out into the dark carrying golden records to explain who we are. We have been shouting into the darkness, desperate for an answer to our one great question: are we alone? We thought 3i Atlas would be the answer. We thought it would arrive and tell us yes or no. But it has done something far more profound. It has not given us a single answer. Instead, it has given us 1,000 new questions. Where did it come from? How did it travel? Did it come quickly using a technology we cannot imagine? Or was it patient drifting for millions of years? Is it a messenger, or is it just an accident? Is it the first one to arrive, or is it simply the first one we have seen? Is it a beginning, or is it an end? We are suddenly faced with a universe that is far more complex and far more interesting than we ever dared to believe. We are no longer children asking a simple question. We are adults standing before a mystery that is deeper and richer than we could have imagined. This is the nature of true discovery. The frontier is not a place where we find certainty. It is a place where we learn to embrace the unknown. The traveller's legacy is not a map. It is a blank page inviting us to wonder. It teaches us that the questions themselves are more important than the answers, because it is the questions that drive us. It is the wonder that makes us human. And so here we are, in our quiet rooms on our small blue planet. The night of December 19th is approaching. The world is watching. All across the globe, humanity is holding its breath. For the first time in our history, we are united not by war or by fear, but by a shared silent awe. We are all looking up at the same sky, waiting for a sign, a signal, a glimpse of this traveller. And as we look up, we are doing something remarkable. We are seeing ourselves. The universe has always been a mirror. For as long as we have existed, we have looked up at the stars and seen only a reflection of our own loneliness. We were the only ones we knew. But now that mirror is changed. There is something else looking back, and in that reflection we see ourselves in a new light. We see how small we are and how fragile. But we also see our incredible burning curiosity. We see our capacity for wonder. We are the observers. We are the part of the universe that has woken up and is now looking back at itself, trying to understand. The Traveller 3i Atlas has not told us our place in the cosmos. It has only given us a new, more profound way to ask the question. As you drift now towards the edge of sleep, let this new reality settle around you. We are not at the end of a story. We are at the beginning of a much larger one. The world is watching. And we, the watchers, are looking into the great mirror of the night sky, finally and forever wondering about our place in it all. Good night, and sleep well.